Hello everybody, I hope you had a great day yesterday, and if there's any questions on the quadratic formula from your work from yesterday, either write down the question on the Google Doc provided, or please feel free to reach out to me for a Google Meet session so we can go over any issues. Today we're going to continue our work with quadratic formula. First one is a word problem that we're going to do here. So we have this problem. It says the number y of northern Rocky Mountain wolf breeding pairs X years since 1990 can be modeled by the function given here. When were there 35 breeding pairs? So if we look at the graph here, 35 would be somewhere in this area. So it's kind of hard to tell exactly there were 35 from the graph. Here since 1990 is down at the bottom, so 35, it's kind of hard to tell exactly, so it looks like we're going to have to use the equation. So the 35 breeding pairs, well, that would be a y value. So we're going to take this 35 and we're going to put it in for y. So we're going to say 35 equals, and the rest of it, 0.20 x squared plus 1.8x minus 3. Now remember, with the quadratic formula, we want it to be equal to 0. So in order to get it to equal to 0, what do? Well, we subtract 35 from both sides. So if we subtract 35 from the left-hand side, we get 0. And if we subtract 35 from the right-hand side, well, nothing would change with 0.20x squared. Nothing would change with 1.8x. But we would get minus 38 as our constant. So now we have an a value, which is 0.2, a b value of 1.8, and a c value of negative 38. So let's go ahead and plug this stuff into the quadratic formula. So we have the opposite of b plus or minus b squared, which is 1.8 squared, minus 4 times a times c. And that's going to all be over 2a, which would just be 0.4. Just jump the gun a little bit on that one. Alright, so that is the quadratic formula all set up. Now with this, I'm just going to use a calculator, and I'm going to figure out what the value is inside of the radical sign. And then I'm going to put it some of this other stuff, so I'm just going to pause it so you guys don't have to painfully watch me writing down the numbers again, and then you'll see that pop up in just a second. Alright, so you'll see we have 1.8 squared, which is 3.24. These numbers all multiplied out give me plus 30.4. So now I'm just going to add these up, take the square root, and I'm left with this. So I took the square root of 33.64, I got 5.8, so I have negative 1.8 plus or minus 5.8 over 0.4. Since I know that my x value has to be positive, because we're trying to find years since 1990, so it's going to be a positive value, I don't have to do negative 1.8 minus 5.8. I'm just going to focus on the negative 1.8 plus 5.8, which in that case would give me 4. So I'd have 4 over 0.4, and 4 over 0.4 equals 10. If this was not a word problem, I'd have to do both of them, because I'd have to find both answers. But in this case, my answer would be x equals 10. So since it's a word problem, I should write out a sentence saying that 10 years since 1990, or in the year 2000, there were 35 breeding pairs. So in the year 2000, there was 35 breeding pairs. Alright, so that is just one way of doing this word problem. Again, if you have any questions on it, please write it down in the Google Doc. If you're ready, we'll move on. So the next part is interpreting the discriminant. The discriminant, what it is, it's the value inside of the radical sign. So the b squared minus 4ac, that is called the discriminant. Now, there's certain things about this discriminant which make sense on how many answers there will be to any quadratic equation. If b squared minus 4ac is a positive number, meaning greater than 0, then you're going to have two answers, meaning that there's going to be 2 points where the quadratic function crosses the x-axis. So there's 2 x-intercepts, there's 2 real solutions. That's what that means. 2 roots, 2 zeros, any kind of wording they want to use. If b squared minus 4ac is exactly 0, well then that would mean that there's one real solution because the vertex is on the x-axis. So that means that there's one real solution or one x-intercept. If b squared minus 4ac is a negative value, well you can't have the square root of a negative number, right? The square root of a negative number is imaginary. So in that case, that means that there is no real solutions or no x-intercepts because either the graph opens above the x-axis or maybe it opens below. It could also look like this, right? Which is the case for all of these. That's a terrible graph, but you guys understand what I'm saying. So any of these could be opening down and have the same exact solutions. All right, so that's just one way of telling how many solutions you're going to have. So we're going to use that knowledge for questions like this. It says determine the number of real solutions of x squared plus 8x minus 3. So it's not asking us what are the solutions, it just says how many of them are there. So we just need to find out, well, what is b squared minus 4ac? Is it positive, is it 0, or is it negative? So b squared would be 8 squared minus 4 times a, which a is 1, times c, which is negative 3. So 8 squared is 64, and this would turn into plus 12, giving me 76. 76 is positive, so since my discriminant is positive, if you refer back to the previous screen, a positive discriminant means that there are 2 real solutions, or 2 zeros, or 2 x-intercepts. All right. So if we then go down here, it says determine the number of real solutions of this one. Well, this isn't equal to 0, so it's not set up in standard form yet. So the first thing you want to do is you want to get it to equal to 0 by subtracting 6x from both sides. And now we want to determine what our a, b, and c value are. A should be equal to 9. B is negative 6. And c is 1. So if we do b squared, we would get 36, because negative 6 squared is 36, minus 4 times a, which is 9, times c, which is 1. So here we'll get 36 minus 36. 36 minus 36 obviously equals 0. So since our discriminant is 0, that means that there's going to be one real solution. We'll just write RS so you don't have to watch me write real solutions again. So there's one real solution because your discriminant is 0. And if our discriminant was negative, there would be no real solutions. All right. So why don't you guys go ahead and try these 3 out, and in a second I will go over the answers. The answers will pop up, and if you have any questions on what those answers are, please be sure to write it down in the Google Doc. So pause the screen and try these 3 out. All right, so here's our answer for 7. I identified A, B, and C. I did b squared minus 4a times c, which gave me 16 minus 16, which was 0, so there was one real solution. All right, for the next one, I'm going to do the same thing. I'm just going to pause the screen and write in my answers, and the answer will pop up in just a second. All right, and for number 8, I had to get it in standard form first, so I added 1 to both sides, and I got this equation here. Identified my a, b, and c. Then I multiply it all out, and b squared minus 4 times a times c. I end up getting negative 20. Since my discriminant is negative, it means that there's no real solutions. So now we'll go ahead and do number 9. Alright, so for number 9, I had to do the same thing where I got it in standard form first, then identified my a, my b, my c value. Then I did b squared minus 4 times a times c. When I did all that work out, I got positive 47 as my discriminant. So since my discriminant is positive, I have 2 real solutions. So that's what you have to do when you're trying to find out how many solutions there are. You just use the discriminant. If it's 0, there's 1. If it's negative, there's no real solutions. And if it's positive, then there's 2. Now this works the same thing when they're asking about how many intercepts there are. So if a question asks to find the number of x-intercepts of a graph, well, you just do the same thing we did before. You make y 0, and then you rewrite your equation. And then we're going to find out if our discriminant is positive, negative, or 0. So we'd have we'd have b squared, which is 9, minus 4 times 2 times 9. So that's our b squared minus 4 times a times c. So that would be 9 minus 72, which gives us a negative 63, which since our answer is negative, there are 0 x-intercepts, or there are no x-intercepts. Alright, so that's how you find out how many x-intercepts there are. Alright, so we're just going to try a few examples with this. So try these 3 out. When you're ready, pause the screen, and when you hit play again, I will have the answers up there and you can review them. And if you have any questions, please write them down on the Google Doc. Alright, so you'll see my answers here up on the screen. I did b squared minus 4ac. So I got negative 23. Since my discriminant is negative, I have no x-intercepts. Remember, just make y 0 for all of these when you're doing it. If I had y to be 0 here, my a value would be 1, my b value would be negative 1, and my c value is 0, which is going to make all of this here equal to 0. Negative 1 squared is 1, so my discriminant is 1, giving me 2 x-intercepts. And for this one, b squared would be 144, and then I'd also have minus 144 when I did negative 4 times a times c. So 144 minus 144 is 0, so there's 1 x-intercept. So that's how you find the intercepts using the discriminant. Now remember, we're not finding the answers, we're just finding out how many intercepts there are, and before we were finding out how many solutions there were. We didn't find the solutions, we were finding out how many of them there were. So that's what you're going to be doing today. So, go on to big ideas and try a few examples out, and if you have any questions, please write them down or reach out to me to set up a Google Meet and we can go through the questions. Alright guys, have a great day, good luck, and we'll talk to you later.